Today we're gonna talk about right triangle trigonometry. And we are gonna use these 6 trig functions to talk about the angles of a triangle. So say we have this triangle ABC, and we have this angle right here, which we're just gonna call theta. Theta. Theta is just a Greek symbol that we use to represent an angle. So just like we'll use x to represent a side, we use theta to represent an angle. So we have 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. And I know it sounds kind of crazy, but it's just talking about the sides of the triangle and their ratio to one another. So sine is equal to, and we're talking about this angle right here, opposite, which is the side opposite this angle, which is A, over the hypotenuse. And this is the hypotenuse of the triangle. So when we talk about sine of this angle, it's equal to A over C. Cosine is, we're talking about this angle, the adjacent side, which is the side right next to it, adjacent, which is B, over the hypotenuse, which is still this side. So this is B over C. Tangent talks about this angle's opposite side, which is still A, over its adjacent side, the side next to it, side B. So A over B. Cosecant is the inverse of sine, and the inverse is just 1 over something. So cosecant is 1 over sine. So if we took 1 over A over C, and we used our little keep, change, flip rules, where we keep the top of the fraction, change the sign to multiplication, and flip the fraction to C over A, multiply that, we get C over A. That's why this is equal to C over A. You can also think of it as, see how this flips the fraction? Well, if you just flip this and say that this is hypotenuse over opposite. That's another way to remember it. Secant is the same thing, it's just 1 over cosine instead of 1 over sine, but the same rule applies. So that's why this ends up being the opposite of cosine, because this is cosine's inverse. For secant, that's what I just talked about. For cotangent, it's just the same as 1 over tangent. Tangent is B over A. So tangent is A over B. So the same rule applies where we just flip them and this becomes B over A, which is the same thing as adjacent over opposite. And we're going to use these little formulas to talk about the angles of a triangle. So we have this triangle right here, and we're gonna find the 6 trigonometric functions of this. So all we're gonna do is fill in what all these equal. The first thing we need to know is what x equals. So using our Pythagorean theorem that we learned about last time, we're gonna take 3 squared plus 4 squared equals x squared. So 9 plus 16 equals x squared. X squared equals 25. Square root both sides, x equals 5. So now we can talk about the triangle because we know every one of its sides. So we're talking about this angle right here. So sine of this angle is equal to opposite over the hypotenuse. So we're going to put 4 over 5. Side 4 is across from this angle, and x, which is 5, is the hypotenuse of this triangle. and the hypotenuse is always across from this right angle. So cosine is adjacent over hypotenuse. So next to it is 3 over the hypotenuse stays the same because this is still the hypotenuse of this triangle. Tangent is opposite, which is 4, over adjacent, which is 3. Cosecant is 1 over 4 over 5, because this is what sine is. So 1 times 5 over 4. So cosecant is 5 over 4. Or you can think of it as hypotenuse over opposite. So the same rule applies for secant, except we do this with cosine. So 1 times, we're going to keep this, change the sign, flip the fraction, and get 5/3, or hypotenuse over adjacent. We do the same thing with cotangent, so 1 over tangent, keep the top, change the sign to multiplication, flip the fraction, and get 3/4, or adjacent over opposite. So those are the 6 trig functions of right triangles. Now these functions only apply to right triangles. So you can't use these rules unless you know that there is a 90-degree angle in that triangle. So now that we know how the angles relate to one another, we're gonna go on to talk about transformations of triangles so we can describe how triangles relate to one another.